Hi, everyone. I'm Doug Black at insideHPC, and today we have with us Vasu Agrawal. He is research engineer at Meta and a user of Liquid's composable computing software platform, specifically the UltraStack architecture with Dell PowerEdge servers that can have up to 20 NVIDIA GPUs. Vasu, welcome.
Thank you. It's a pleasure to be here.
Okay, tell us a little bit about the project that you're working on at Meta and give us an idea of the computing requirements and demands.
Absolutely. I work on codec avatars broadly. We are trying to build photorealistic telepresence effectively. So over the past few years, people may have seen some of the work that we've published in having super photorealistic humans that are indistinguishable from reality is the term we like to use around here. We want to make it so when you put on the VR headset, you feel as though you're transported to another place. Like I could be in your office having this conversation instead of over a VC like we're doing right now.
Okay, tell us about the challenges you were facing, some of the shortcomings of your previous computing resource for this project, and how it sort of got in the way of the goals you're
Yeah,
seeking.
absolutely. So I'll go into a little more detail on the project first. So for this photorealistic experience, right, we want to have avatars and we want to have environments. The most impressive technology out there at the time was NERF, neural radiance fields, and they're very, very photorealistic. The problem is they're very compute intensive. And so we started with just a couple GPUs, and that's sort of the first approach. You can have a few more GPUs in your PC, but it's still not, and you can parallelize it across that, but it's only a little bit better. And so the shortcoming was we just weren't getting fast enough. So the approach we were targeting was, can we get to higher frame rates by adding more and more GPUs? I stumbled upon Liquid's latest offering, which was their what was now called the UltraStack, then called something else, and reached out to them. We got a trial unit in, and then it met a lot of the performance needs and performance criteria that we were looking for. And so we pursued some more work with them and made it collaborated and made it work for our application.
So tell us a little bit about Liquid UltraStack and how it meets your requirements.
So Liquid intends for their solution, I believe, to be used to compose GPUs across multiple PCs. That is, the intent is you have servers, depending on the workload that you're doing on a, say, cluster machine. One server might need one GPU, one server might need 10, and then later that those needs might switch or they might balance out more over time. That's not what we have. We just want as many GPUs as possible on a single machine. So when the first version of this system that we built, affectionately known as the Turtle, we built with 20 GPUs in two different Liquid chassis, 10 slot enclosures each, and then connected those to one server. And that works, and we don't use any of the composability. We just compose it once and it's done. We, of course, take advantage of the fact that in doing the composability, Liquid has to have all the traffic go through a PCIe switch, or a chain of them actually. And that means that all the GPUs can communicate with each other very efficiently without having to go through the CPU. So we still take advantage of the hardware performance characteristics that we get, that the composable solution also gives us. We just don't take advantage of the composability. However, we recently built a version 2 of the Turtle, and what we learned, which is largely the same, but one of the things that we just newer GPUs primarily, and what we learned was the the likelihood of failure of having a single machine is not great. So in the second rack, what we actually did was we put two almost identical machines, with the first one being a little bit more powerful for just as a plan A effectively. And then the composability, which we've tested and it's fantastic, lets us dynamically switch GPUs between the two machines. Both are running Windows, by the way, which is notorious for not necessarily supporting this PCI hotplug super well. But whatever either Microsoft is doing, whatever Liquid is doing, even on our Windows 10 servers, which, yes, Windows 10, not Windows Server, even on our Windows 10 servers, the composability worked great. You can hot plug the GPUs, you can take 19 of them out, you can take 20 of them out. Windows just does the right thing, and then, or the entire stack rather, just does the right thing. You can move them around. So on our second rack, maybe to summarize, we've been able to use the composability to just have a fallback plan, which is really great when you've got only one of these machines that you're bringing with you, or one of these racks rather, that you're bringing with you to a demo, and you're showing it to hundreds of people at a conference or to a VIP or something. You really want the reliability that you get from having a backup plan, which the composability makes it super easy for us to do.
Vasu, can you give us one or two on the performance end of things, one or two before and after comparisons on UltraStack performance, some aspect of your workload where you saw marked performance improvements?
Yeah, absolutely. We published a paper not too long ago at SIGGRAPH Asia in December, and in that paper we have a chart showing some of the performance characteristics across a number of GPUs for our approach. The short version is that we get somewhere between we go from at one GPU looks like we're at about 18 FPS for one specific example, and we get up to about 100 or so. So 5 to 6x improvement. And more importantly, it takes something that was not previously possible into something that is now actively possible and used. And it that is the value for it of it for us. It is now, yeah, things that were previously impossible can now be seen in real time.
Yeah, on the GPU lead time issue, how long did it take for installation and access to UltraStack with NVIDIA L40S GPUs?
So, like I said, we've built two different units of this. We have our first unit, which uses the A40s, and for VR specifically, we needed a GPU that has a display output on it, and so that's what we selected for the first unit. And of course, we needed at least one of those anyway because it had a display output, which we needed to be able to run to output to a headset. When we go to V2, we were looking at either doing the A40, the L40, or the A100. And it just so happened, sort of fortuitously, that right when we were about to pull the trigger on making a decision on what GPUs we were going with, NVIDIA announces the L40S, but Liqid was very accommodating and validated the new hardware as soon as it came out, basically for us. So we were able to upgrade to the new L40S, and yeah, the performance has been substantially improved over the A40. But yeah, the availability from the L40S has been really good for us.
Okay, well, thanks so much, Vasu. We've been with Vasu Agrawal of Meta. Thanks so much for your time.